And then going to part B, we want to use the second method 2 of perpendicular lines to find the equation of the tangent to this circle at that point. To visualize it better, we draw a circle, then we assume that the tangent is touching the circle at this point and it is coming from maybe point B. But the coordinates of the point where the tangent is drawn are not given. So the point where the tangent meets the circle is where I have the coordinates 5 and 6. So let me just call it point A to make my work organized. And we know that the center of the circle is somewhere in the middle there, and the radius is perpendicular to the tangent. They meet at right angle. In the method of perpendicular lines, we need to get the gradient of the radius here, r. For us to get the gradient of the radius, it is important for us to have the coordinates of the center. So let me say center C has coordinates. This is the equation of a circle in the expanded form. You can compare it to the formula and then you get the coordinates of the center A and B. In this case, the coordinates of the center are 2 and negative 3. Those are the coordinates of the center. Now, what do we need to do? We need to find the gradient of the radius, which is a line. The radius is a line from the center to any point on the circumference. After getting the gradient of the radius, then we apply the property of gradients of perpendicular lines, and then we get the gradient of the tangent. So let me begin by getting the gradient of radius. Always keep in mind that a radius is just a line joining the center of the circle to any point. So for us to get the radius, for us to get the gradient of the radius, we have 2 points already here. We have the point at the center and the point on the circumference. If you have 2 points on the line, you can find the gradient of that line. Or if you have 2 points as the end points of the line, you can find the gradient of that line. So we're going to treat these 2 points in a manner that gives us the gradient of the radius. So the 2 points are 2 and negative 3, which is the center, and then 5 and 6, which is the point on the circumference. So for us to get the gradient, the formula m is given by changing y, which is y2 minus y1 out of x2 minus x1 is equals to, then you come and name your points the way you want: x1, y1, x2, y2. You must know this in your senior 2 coordinate geometry. Now we substitute y2, 6 minus y1 is negative 3 out of x2 is 5 minus 2. This here gives us 9 out of 3. Divide, get 3. So the gradient of the radius is 3. Okay, that is the gradient of the radius. But we have said that the radius is perpendicular to the tangent. The radius is perpendicular to the tangent. Let me put it here, but the radius is perpendicular to the tangent. That means they are meeting at right angle. Now, what does it mean? This implies that when you use the concept of perpendicular lines, the product of the gradients of perpendicular lines is negative 1. That is m1 times m2 equals to negative 1. So what can I do? I'm going to call the gradient of the radius m1, okay, which is 3. Here it is known as 3. So if I substitute for 3 here, it implies that m1 is 3. This is my m1. So I'm going to have 3 times n2 equals to negative 1. n2 in this case is the gradient of the tangent. Therefore, n2 equals to negative 1 out of 3. This is now the gradient of the tangent. That is the gradient of the tangent. Now, since we have the gradient of the tangent and we have one point of the tangent, this same point A here is for both the radius and the tangent. This point is shared by both the radius and the tangent. So, since I have the gradient of the tangent and one point on the tangent, I can find the equation of the tangent. Why? Because the tangent is a line and this is the gradient of a line. Therefore, using point A, which is 5, 6, you cannot use point C when you are finding the equation of the tangent. Why? Because the tangent here is not passing through point C, and point C is the center of the circle, and a tangent will never pass through the center of the circle. It will always touch the circle at one point, but will never enter the circle and pass through the center. So we are going to use this given point and then the gradient n2 to find the equation. Now what do we do here? We say y is given by mx plus c. That is the equation of a line. The tangent is a line. So now we call this x and y. Substituting here for y is 6. So 6 equals to, what is m? M is negative 1 out of 3. What is x? X is 5 plus c. So from here we can get c. Simply press your calculator and get the value of c. You can do more steps to get c. Negative 1 times 5 divided by 3. 6 minus answer. So c, I'm getting 23 out of 3. After getting c, which is the y-intercept, this is the point where the line meets the y-axis. Therefore, now the equation becomes y equals to n. What is n? Negative 1 out of 3 x plus c. What is c? C is 23 out of 3. So this is the equation of the tangent in part B.